let's do some calculus, huh? Let's get back to it after taking some time off in 10.1. We did our little derivation so we know our first derivative and our second derivative on y with respect to x. Knowing that if we're dealing with a parametric equation, we got some chains and shit going on here. So we got to be real careful with how we use our formulas. Well, I thought, what the hell? Let's go into your textbook. Let's go find one of the problems you're doing and choose one of the challenging ones. So this is number 16 out of 10.2. This will be the last one in that section of 11 through 16, which just asks you to do a couple things. Ask you to go find the derivative on y with respect to x and the second derivative on y with respect to x. And then it's going to ask you to find for which values of t is the curve concave up. Probably should have that in there, but you know, math, not English. And then it gives us our parametric equations. The x is equal to cosine of t, y is equal to sine of 2t, and we're going to keep our t's in between 0 and pi for the values we're looking for t to be concave up or upward. Well, let's not dilly-dally, let's get after it. Let's go find our dy dx. Our dy dx from before, that was dy dt over dx dt. This is mellow, and I think we can just do this. You know what I mean? I think we could just look at y. You think we could just look at this and figure out what the derivative is with respect to t and just write it in? Of course we can. The only thing that can end up happening here is getting integration and derivatives backwards, right? Happens to me a lot. So the derivative on sine is cosine, and then we leave the interior alone. But we got to multiply by the derivative of the interior, and that's 2. We get 2 cosine of 2t. Now we need to find our dx dt, so we got to be looking at that x with respect to t. So that's going to become derivative of cosine is negative sine of t. Okay. Sweet. We did it. Super proud. I'm happy. Did this thing. Look at this little answer. Woo! But now we have to go get that second derivative. So we've knocked one thing off our list here, right? We went and found our dy dx. Well, now we got to go find our second derivative. So the second derivative on y with respect to x. Now I wrote this in a little funky. It's different than the way your book writes it. I'm not even sure if this is 100% notationally okay to write it this way. I wrote the derivative on y prime with respect to t over dx dt. Now the difference is it's essentially like you're taking the second derivative on y. You're not. It's not working the same way. What this is not equal to, what's that? It's not equal to the second derivative on y with respect to t, and then the second derivative on x with respect to t. It's not. Don't freaking do that, okay? Don't do that. It's not going to work out that easy. We got to do a little bit of work. All right, back to the problem. Sorry, got a little sidetracked. I think we can find. Let's just start off right off the bat. I mean, let's go. You know what I mean? Let's go get dx dt. I think we might already know that. Dx dt, what could that be? That's just negative sign. Let's write it in. Let's get that negative sign in there. So we got a negative sign of t hanging out down below, but now we need to go take a derivative on y prime. You know, y prime, right there. This one right here. This y prime. This thing that we have highlighted in blue, we need to take a derivative on that with respect to t. So why don't we jump aside and handle this one? Let's go through. So if this is dy dx, we need to take a second derivative on this with respect to t. So do you remember your chain rule? Do you want to do this was I want to call that negative cosecant? I'm just going to when I say chain quotient. So let's go. Let's get after that thing. That little loady high, high-y low bullshit. So low times the derivative of high. Uh-oh. So the derivative of high, let's do this together. So that's going to be negative 4. Negative 4, but we'd have to change the sign in the front of our already negative. So we get 4 sines of 2t. Yep, that's right. That's right. So 4 sine t, sine 2t. Pretty sure I'm right there. And then low d high, so we leave that 2 cosine of 2t. Don't do shit with that. D low, the derivative of negative sine is negative cosine, so let's just change the sign in the center there. Call that cosine, then square the bottom. That just becomes sine squared of t. Oh, let's just take that, pop it in, and I think once you clean all this up, you're gonna find out you have 4 sine of t, sine of 2t plus 2 cosine of 2t, cosine of t, and that's all over negative sine cubed of t. That's actually how that would have worked. So, right, because we just bring down our piece from over here, huh? We bring that right down into here. If we divide by the negative sign, it becomes the negative sine cubed. You get it. So boom, we got it. There's our second derivative. We're super happy with ourselves. That's not very cleaned up though, is it? It's not very clean, but oh, it's not a big deal, right? Who cares? We don't like cleaning shit up. Until we need to go figure out that there's still one more part to this problem. It's asking for which values of t is the curve concave up. How the hell are we going to do that? What does it mean for it to be concave up? Doesn't that mean that the second derivative, something to be, for us to consider that idea, the concave up, the second derivative with y with respect to x, wouldn't that need to be greater than 0? So for all values of x, or, oh shit, t, or that's greater than 0? So I think the way we should probably do this is find out where it equals 0. It's kind of strange. We're going to find out where it equals 0, get some boundary points, then we can play some games to figure out what this value might be. So none of these steps are all that challenging, but this next one, if you're not very strong with your trig, this might be pretty shitty. So what we want to do is just set this thing equal to 0 and do a little bit of work. Now, there's a beautiful thing. I'm only going to write the numerator. I'm not writing the damn denominator. If you still think the denominator can make everything equal 0, you might want to rethink your major if you've gotten this far. Yeah, so let's get that shit out of there. And of course, limits do that, but not functionally. All right, so we better create some 0 products. I don't see anything to just factor out here. Oh, let's just start. Oh, yeah, we do. There's a 2. There's a 2. Wow, look at me go, huh? Got rid of something. Now we need to start changing stuff. Now, what's not so tough is, oops, get T in there, is this one here. That's going to be 2 sine T, cosine T. It's always this this other one here. And I'm going to change it to sine squared just because I don't know what else to do. I don't know. I haven't done this problem yet. I'm just going to call it 1 plus, 1 minus 2 sine squares of t times cosine of t. Let's see if anything cleans. So that's going to become 4 sine squares of t cosine of t plus cosine of t minus 2 sine squared t cosine of t. Okay. Whoo! At least there's a freaking cosine of t on all these terms, and I think we can clean some shit up. Oh, look at that. Oh, this is nice. 4 sine squared t. Oh, we got some like terms. Let's put that shit together, huh? Sweet. I did not think I was going to pick the right one. So we got 2 sine squares of t cosine of t plus cosine of t, right? Those two put together. Now let's factor out that cosine of t. Oh, good news. And we'll be left with 2 sine squares of t minus plus 1 plus, come on, keep sine there. And now we can use our 0 product principle. Oh shit, these are like these trig equations. You know I'm excited right now. So we can say that cosine of t is equal to 0, or we can say that 2 sine squared of t plus 1 is equal to 0. Well, cosine equals 0 at all odd multiples of pi over 2, so in that interval where we between 0 and pi, we're going to get pi over 2. That's the only one. 3 pi over 2 works too, but that's not in the interval. So let's go deal with our other one over here. We subtract it over. We get 2 sine squares of t is equal to negative 1. We divide that, and we go up. Oh. Did we just say a positive number is equal to a negative number? Well, that's a bunch of freaking nonsense, so we're just going to cross that shit out right there and just stop looking at it because we're not going to want to force anything. Now, for us to know whether something is going to be concave up or concave down, we're going to have to go back to our original, right back up here. We're going to take a look and see what value. So let's do some test points, huh? So what happens right through here? So we know that there's only one spot where the second derivative equals 0. So then everything from the left, and oh, let me change this a little bit. Let's do one of these and say from 0 on up to, oops, this is pi over 2. And then to pi, right? There's our interval between 0 and pi. One spot where it equals 0 is at pi over 2. So we just check to the left. We can find a value that's negative. We'll keep it negative. We find something on the right that's positive. You know what I mean. Let's get it. So let's plug in a value. Let's choose something really freaking simple. And I'm just going to choose the boundary point, even though we really shouldn't do that. Actually, let's just go ahead and use pi over 4. Let's be proper about this thing. Don't worry, we're almost to the end of this. I'm proud of y'all for hanging out in this. So we're going to get, now all I'm going to do is play a game when I plug it into the second derivative going. So it's 4 times a positive. Actually, let's do this. Let's do this. Right up here, right next to it. Let's just say we have a positive times, and then sine of 2t, sine of pi over 2, that's a positive. You have a positive times a positive plus 2 times cosine of 2 times pi over 4, that's pi over 2, that's 0. Okay, so that's positive. And then we have a negative value down below. So a positive and a negative, that means that shit's negative. Notice I didn't use any numbers. I'm just looking to see what would happen. Now, if we were to choose, say 3 pi over 4 over here, we could check and see if this is going to have a positive or negative concavity. So we're going to plug that right back in. Now let's play that game one more time. So we're going to have that up top. We got the 4 times, and then we're like sine of 3 pi over 4. That's the second quadrant. That shit's positive. And then the next thing we do is we're like, all right, sine of 2 times 3 pi over 4. Well, 2 times 3 pi over 4 is 3 pi over 2. And sine of 3 pi over 2? Shit, that's negative. Now when we go back, we got 2 times our cosine of 2t. 2 times 3 pi over, that's 3 pi over 2, cosine 0. So that shit is, that's a 0 over there. Well, actually, it's not going to be multiplied. Nothing's going to be there. So what we have up top is a negative. Then we pop in 3 pi over 4 into sine of 3 pi, or sine cubed of t, and it's all negative, and that's negative. So if you have a negative over a negative, that creates a positive. Hence, we have a positive up top. Hope you caught all that. That was pretty quick. So we are going to say that the derivative is when we have our t values are between 0 and pi over 2. It's going to be concave down. So that's not the solution we want. We wanted to know where it's above. So that's going to be from pi over 2 to pi. And that will be our